have a lot to cover. All right, how many times does this graph cross through the x-axis, Damariana? What would you say for that? How many times does it cross the x-axis? None, exactly. It doesn't come down far enough. You want me to put that on my desk for you?
It's my promise.
Oh, okay. All right, how many times does it cross it? None. So you would say it has no x-intercepts. The axis of symmetry, when you write that equation, make sure you start it off with x equals. And it's whatever this number is right here. So what's that number? It goes down the middle. So the vertical line that goes down the middle is at x equals what? 3. Do we think A is positive or negative? And how do we know? It's a smile, so is it positive or negative? What would you say, Monasia? Positive. And what is the domain for every quadratic? Kalavin, you know the domain? What's the domain? It never changes. It's for every graph. Johan, what's the domain? Negative infinity to positive infinity. All right, guys. So now we're going to finish out with operations on complex numbers. So in your blue packet, I think we're on page 15. Yeah, we are. Okay. All right. So what is a complex number? It's when you have a real number plus an imaginary number. That is what a complex number is. And when we do our operations, we simply combine our like terms. So it's actually pretty easy to do. So when we do our operations with a complex number, that's simply when you have a real number, which is a number that doesn't have an I, and an imaginary number. So if you look at this Venn diagram we have here, notice that all on the outside, all of these numbers have both. So this is imaginary, this would be imaginary, this is imaginary. All of these are imaginary. And then we have real numbers. This is a real number, this is a real number. All of these are real numbers. So when you try to bring them together, it's called a complex number. And who remembers, what did we learn yesterday? If you have the square root of a negative, so for example, I have the square root of negative 15. The first thing we would do is take away the negative 1 and the 15. You have to separate them. And what did we learn yesterday? What is the square root of negative 1? I. So this one would actually be I root 15. Okay, so whenever you do operations, all we can do is combine like terms. We're going to combine like terms. That's all we can do. Combine like terms. But if it's subtraction, we have to distribute the negative first. And if you look at the back of your homework 3, which is due tomorrow, I did put that hint on there. to help you all with that. So if there's a plus sign, all we do is add the like terms. So go ahead and do that. So the real numbers would be 4 and 2. Add those together. 7i and 3i. Add those together. Oops. Figure out what that would be. So 4 plus 2. 4 plus 2 is 6. So that would be 6. Oops. That's what I get when I add these together. And then when you add these together, what do you think 7i plus 3i is going to be? Wait, what is it? What'd you say one more time? 10i, yeah. Sorry, I can't hear because I'm congested. So this ear kind of clogged up. So that would be your answer. Hold on. Pen is acting up too. That would be the answer to number 1. Now, when it's subtraction, though, we can't just combine them right away. I'm going to rewrite the first parentheses. And then I need to do a sign change. Both of those terms in the parentheses are going to flip. So do you see how that 7 is positive? It's going to change to -7. And then the -3i, what do you think that's going to change to? A +3i. Good job. So now we're ready to combine our like terms. I have 5 and -7. Go ahead, add those together. What is 5 plus -7? -2. And then we're going to add our imaginaries, 6i and 3i. 6 plus 3 is 9i. And that's a +9i. So I'm going to put a plus sign in the middle. And that would be my answer. All right, try to do number 3 by yourself. It's subtraction, so you're going to distribute the negative first. Distribute the negative. This is just like number 2. Do the sign change, and then combine the like terms. Don't forget to put the I. All right, let's go ahead and look at what we got. So the first thing I did was I distributed the negative. So that made that +2 become a -2. And the +7 switched to a -7. Then I combine my like terms. 3 minus 2 is 1. 5i minus 7i is negative 2i. Who had that right? Just curious. All right, let's do the next one. Let's look at number 4. Number 4 is addition. So do I need to do a sign change? Nope, just combine your like terms. So 4 plus 4 and 9 minus 9. So your answer can be written as 8 plus 0i, or you could really just say 8. So when we added those together, we ended up with just a real number. It had no imaginary. So it's just a real number. All right, try to do number 5 by yourself. Go ahead and do your sign change. And then combine your like terms. All right, somebody want to volunteer what they got for their answer? 9i. Who? Anybody else get 9i? Yep. So these cancel because you get 0. And when you add these, you get 9i. So because our real number canceled out, this is what we call a pure imaginary. It's only complex when you have both. All right, last one. Go ahead and distribute the negative. So that would be 7i minus 4 plus 2i. So there's only one real number, so he doesn't have a friend to add to. Okay, so the negative 4 comes out first. And when you add the 7i and the 2i, what did you get? 9i. And that's a positive 9i, so that would be your answer. And that is a complex number because it has a real and an imaginary. Okay, everybody take out homework 3 and flip it over to the back. Let's go ahead and work on getting that turned in today. You should have the front side finished, and work on getting that finished today so you can get that turned in.